We'll start in about a minute. Today we'll be in Chapter 9, Section 6 on graphing quadratic functions. So if we let the variable y be a quadratic function of the variable x, then its standard form is y equals ax squared plus bx plus c, where a, b, and c are real numbers, and a does not equal 0. The graph of y equals ax squared plus bx plus c in the xy plane is a parabola. If the leading coefficient a is positive, then the parabola opens up. And if the leading coefficient a is negative, then the parabola opens down. So in the xy plane, we could have a parabola that looks something like this. It's not the best parabola, but if you look in the software or in the textbook, you'll see a better picture. But in this one, the parabola opens up, so that means the number a is greater than 0. And the parabola could be positioned anywhere in the xy plane. So x-axis and y-axis. If you have a parabola that opens down, this parabola opens downward, so this time the number a is negative, a is less than 0. Okay, there are some things to note. If the parabola opens down, the highest point on the parabola is the vertex. And if the parabola opens up, the lowest point on the graph is the vertex. And through every vertex is a vertical line. We normally don't graph it, but this vertical line, this vertical dashed line that passes through the vertex, is called the vertical line of symmetry. There's always a vertical line of symmetry for every parabola. It's the vertical line that passes through the vertex. So that's the vertical line of symmetry. And remember that in the xy plane, the equation of a vertical line is x equals a number. So if you have a quadratic function in standard form, y equals ax squared plus bx plus c, then the equation for the vertical line of symmetry is x equals negative b over 2a. So x equals negative b over 2a. And that that same number, negative b over 2a, is the x-coordinate of the vertex, negative b over 2a. The y-coordinate of the vertex, well, that's the number you get when you replace x in the function, when you replace every x with negative b over 2a. So here I'll just write it in raw form, without simplifying too much. Replace every x with negative b over 2a. So we have a times, instead of x squared, we're going to square negative b over 2a. And then we're going to add b times negative b over 2a, and then add c. Okay, so this y-coordinate can be simplified quite a bit, but this is how we would go about finding it in general. Okay, the y-intercept of y equals ax squared plus bx plus c is the ordered pair 0, c. So in general, if you want to find the y-intercept, replace x with 0. And do the arithmetic. Okay, we've encountered x and y intercepts before when we were learning about linear equations of the form y equals mx plus b. With linear equations, we found the y-intercept by replacing x with 0 and then doing the arithmetic, solving for y. Well, the same concept is true for graphing parabolas. So why does that work? Why does replacing x with 0 help us find the y-coordinate of the y-intercept? Well, we'll have plenty of opportunities to review this idea, but just briefly, remember that the y-intercept is the point on the y-axis that the graph crosses, wherever that happens to be. But on the y-axis, every x-coordinate is 0. So to find the y-intercept, you replace x with 0 and then solve for y to find the y-coordinate. Okay, the graph of a quadratic function in the xy plane may have 2 x-intercepts, or 1 x-intercept, or no x-intercepts. So a parabola that has 2 x-intercepts, but you could look at either of those two drawings that I've already done. If you have a parabola that opens up, if the vertex is below the x-axis, then you know that you have 2 x-intercepts. If the parabola opens down and the vertex is above the x-intercept, or above the x-axis, then you'll have 2 x-intercepts. But I'll just draw another picture here. So in this picture, this parabola crosses the x-axis twice. So remember, when the graph crosses the x-axis, those are x-intercepts. So there are two x-intercepts in that picture. So what could happen if you have just one x-intercept? Or what has to happen? If there's just one x-intercept, how could that happen?
Would it happen if it was tilted to the right or to the left? Like where it's just the vertex would be on the x?
The parabola?
Yeah.
Opening to the right or to the left?
Yeah.
Well, if y is a quadratic function of x, its graph in the xy plane is a parabola that opens either upward or downward. So if y is a quadratic function of x, it can only open up or down.
So therefore, would it have to be just a straight line?
That,
It would have to be just a straight line to only have one.
well, a parabola is never a straight line. So a parabola always has this shape. Yeah, someone online says the vertex touches. Yeah, so if the vertex is on the x-axis, then there's only one x-intercept. So if you have a parabola that opens down and it only has one x-intercept, then the vertex is the x-intercept. So this is one x-intercept. So the vertex is the only x-intercept in this picture. Okay, if you have no x-intercepts, then what would that look like? There are infinitely many examples of parabolas that have no x-intercepts, but we'll just draw one. So can you describe what that kind of situation looks like? The parabola has no x-intercepts. Anybody know?
Would it be just the case like it just wouldn't touch the x-intercept? You'd still have that thing, but it would never touch the. It just doesn't.
Yeah, if you have a parabola that opens upward and the vertex is above the x-axis, then there's no x-intercept. If you have a parabola that opens down and the vertex is below the x-axis, then there are no x-intercepts. So here's two examples, two drawings of parabolas with no x-intercepts. No x-intercepts. So you might remember when we were graphing straight lines, equations that have the form y equals mx plus b. We also had a standard equation, ax plus by equals capital C. But we always found the x-intercepts the same way. We replaced y with 0 and solved for x. The same is true for finding the x-intercepts of a parabola or of a quadratic function. To find the x-intercepts, if there are any, replace y with 0 and solve the resulting quadratic equation for x. So that is, solve the quadratic equation ax squared plus bx plus c equals 0. So here we're assuming that we started out with a quadratic function y equals ax squared plus bx plus c. And to find the x-intercepts, we replaced y with 0. So replace y with 0, we get 0 equals ax squared plus bx plus c. Over here, I just wrote the equation with the terms in the opposite order, but those two equations are equivalent. So why do we replace y with 0 when we want to find the x-intercepts? We replace y with 0 to find the x-intercepts because every x-intercept has a y-coordinate that is equal to 0. Okay, so in the xy plane, every point has an ordered pair, xy. And if you pick a point on the x-axis, the x-coordinates will be different, but the y-coordinate will always be 0 if it's a point on the x-axis. And a graph of a parabola or a line that touches or crosses the x-axis is an x-intercept. And so every x-intercept has a y-coordinate that's equal to 0. So that indicates to us a procedure for finding the x-intercepts. Replace y with 0 and solve that equation for x. Okay, if things are still confusing, hopefully a little bit later when we start to graph parabolas, maybe those will clear up. Okay, but here's this next statement. The graph of y equals ax squared plus bx plus c consists of infinitely many ordered pairs of the form x comma y in parentheses. So think of y equals ax squared plus bx plus c as a formula for finding the y-coordinate of an ordered pair xy that goes with a chosen x-coordinate. So I'll expound a little bit on that. We can pick x to be any number, any real number that we want. And then we replace x with that number that we picked, and we do the arithmetic, and that will tell us what the y-coordinate is that goes with the x-coordinate that we chose. We get to choose the x-coordinate. After we choose an x-coordinate, we use this formula to find the y-coordinate that goes with it. And then once we know what the ordered pair xy is, we plot it in the xy plane. And if we do that enough, we'll be able to see what the graph of that quadratic function looks like. We already know some things. We know that the graph is a parabola. If the number a is positive, we know that the parabola opens up. And if the number a is negative, we know that the parabola opens down. Okay, so if you have a calculator to help you with the computations, well, there's really no excuse for not being able to graph a quadratic function. If you pick enough ordered pairs and plot them in the XY plane, then you can connect the dots to see what the graph looks like. Okay, we'll start looking at graphing some quadratic functions by plotting points. So we'll identify the vertex, the X and Y intercepts, and the line of symmetry. Hey, this is perhaps the most basic of all quadratic functions, y equals x squared. So we'll pick a few x values and then use this formula to find the corresponding y values. Then we'll plot those points in the xy plane and then afterwards connect the dots. So for y equals x squared, I'm going to pick x values -2, -1, 0, 1, and 2. So when x is -2, what's the y coordinate that goes with it? Yeah, when you square the number -2, you get 4. Right, this is a formula for finding y coordinates when you pick an x coordinate. When x is -1, then the y coordinate is -1 squared or +1. When x is 0, the y coordinate is also 0. 0 squared is 0. When x is 1, the y coordinate is 1 squared or 1. And when x is 2, the y coordinate is 2 squared or 4. So with a little practice, you'll be able to sketch graphs of parabolas. So here's our x-axis and y-axis. Okay, so if we plot the points, -2, 4 is up here, -1, 1 is about there, 0, 0 is right there, 1, 1 is here, and 2, 4. So remember that there's curvature in the parabola, so the parabola looks something like this. Okay, the vertex. The ordered pair for the vertex is 0, 0 in this picture. The x-intercept, well, there's just one x-intercept. It's the point 0, 0. And there's one y-intercept, which also happens to be 0, 0. And the vertical line of symmetry. What's the equation for the vertical line of symmetry? So the line of symmetry is an equation. It's not just a number. The vertical line of symmetry is the line that passes through the vertex. So the y-axis is the vertical line of symmetry, but what's the equation for the y-axis? X equals 0. So the equation for the y-axis is x equals 0. The reason is that every point on the y-axis has an x coordinate of 0. Okay, the next one, y equals negative x squared. In the example that we just finished, y equals x squared, the coefficient of x squared is 1, so we should expect a parabola that opens up. For this function, the coefficient of x squared is negative 1, so we're expecting a parabola that opens downward. For this one, let's use the same x values that I chose in the previous one. -2, -1, 0, 1, and 2. And then this is a formula for finding y-coordinates. The y-coordinate that goes with -2 is the negative of the number -2 squared, or -4. When x is -1, the y-coordinate is the negative of -1 squared, or -1. When x is 0, the y-coordinate is 0. When x is 1, the y-coordinate is -1 squared, or -1. And when x is 2, the y-coordinate is the negative of 2 squared, or -4. Okay, so this time the parabola opens down. -2, -4, -1, -1, 0, 0, 1, -1, and 2, -4. Okay, so the x-intercept is 0, 0 again. The y-intercept is 0, 0. The vertex is 0, 0. And then the vertical line of symmetry is x equals 0 again. Okay, those are the two basic examples, and then we'll look at progressively more complicated ones. So the next one, y equals x squared plus 1. So for this one, I'll pick the same x coordinates that I've been picking, -2, -1, 0, 1, and 2. And then just be careful with the arithmetic. When x is -2, the y-coordinate is -2 squared plus 1, or 5. When x is -1, y is -1 squared plus 1, which is 2. When x is 0, y is 0 squared plus 1, or 1. When x is 1, y is 1 squared plus 1, which is 2. And when x is 2, y is 2 squared plus 1, or 5. Okay, so we plot those points. Okay, so -2, 5, -1, 2, 0, 1, 1, 2, and 2, 5. Okay, this one has no x-intercepts. No x-intercepts. It does have a y-intercept. So every quadratic function has a y-intercept. the x coordinate is always 0 for the y-intercept. So in this one, the y-intercept is 0, 1. And the vertex is also 0, 1. And the line of symmetry, it's the vertical line that passes through the vertex, which is x equals 0 again. Okay, the next one, y equals x squared minus 1. Okay, I'll pick the same x coordinates, -2, -1, 0, 1, and 2. And then we'll find the y coordinates. When x is -2, the y coordinate is -2 squared minus 1, which is positive 3. When x is -1, the y coordinate is -1 squared minus 1, which is 0. 1 minus 1 is 0. When x is 0, 0 squared minus 1 is -1. When x is 1, the y coordinate is 1 squared minus 1, which is 0. And when x is 2, the y coordinate, 2 squared minus 1 is 3. Okay, -2, 3. -1, 0. 0, -1. 1, 0, and 2, 3. Well, two of our points happen to be the X intercepts. -1, 0, and 1, 0. The Y-intercept is 0, -1. And the line of symmetry, I'll abbreviate symmetry. The line of symmetry is the vertical line that passes through the vertex, which is x equals 0 again. The vertex is 0, -1. Okay, let's try the next two. Y equals -x squared plus 1. So as unpleasant as these exercises might be, you're better off going through them and so that you'll be able to do the arithmetic correctly. You have to always watch out for the arithmetic involved. So for this one, I'll pick the same x coordinates, -2, -1, 0, 1, and 2. When x is -2, what's the y coordinate?
That'd be -1.
How much?
Would it be -1?
-1? No. Okay, so remember the order of operations. If x is -2, the number negative 2 squared is 4, but then we take the negative of that, which is negative 4, and then negative 4 plus 1 is negative 3. When x is negative 1, first square negative 1, which is 1, then take the negative of 1, which is negative 1. Negative 1 plus 1 is 0. When x is 0, negative 0 squared is 0. 0 plus 1 is 1. When x is positive 1, negative 1 squared is negative 1. Negative 1 plus 1 is 0. When x is 2, the negative of 2 squared is negative 4. Negative 4 plus 1 is negative 3. Okay, so negative 2, negative 3, negative 1, 0, 0, 1, 1, 0, and 2, negative 3. So rough graph, but okay, the X intercepts negative 1, 0, and 1, 0. The Y-intercept is 0, 1. That's also the vertex, 0, 1. And then the line of symmetry, x equals 0 again. Maybe you've noticed for each of the examples that we've done so far, I chose just 5 x values, but the middle x value, 0, in each of these cases is the x coordinate of the vertex. So in general, we'll get to more complicated examples, but in general, my strategy is usually to pick 5 x values so that the middle x value is the x coordinate of the vertex. And then I have 2 numbers smaller than that x coordinate and 2 numbers bigger than that x coordinate. If I pick my 5 x coordinates that way, then I'll be where the action is, that is where the vertex is and the points surrounding it. Okay, but let's try the next one. Y equals negative x squared minus 1. So negative 2, negative 1, 0, 1, and 2. Yeah, another thing about symmetry, I'll make a note here. Notice the symmetry. We've encountered the symmetry in all of the examples so far, but I'll point it out here. Well, from experience, I know just by looking that the x coordinate of the vertex is 0. So I pick 2 x values smaller than that and 2 x values bigger than that. So starting at -2, replace x with -2. -2 squared is 4, but -4 is -4. -4 minus 1 is -5. When x is -1, -1 squared is 1. The negative of 1 is -1. -1 minus 1 is -2. And when x is 0, -0 squared is 0. 0 minus 1 is -1. Okay, by symmetry, I know that the y-coordinate that goes with x equals 1 is the same y-coordinate that goes with the x-coordinate -1 by symmetry. I also know by symmetry that the y-coordinate that goes with x equals 2 is the same as the y-coordinate that goes with -2. But you don't have to leave it to chance. You can always just do the arithmetic. When x is 1, -1 squared is -1. -1 minus 1 is -2. When x is 2, 2 squared is 4. -4 minus 1 is -5. So just to reiterate, 0, -1 is the vertex. The x-coordinate that I chose smaller than 0 is 1 unit below 0. The x-coordinate bigger than 0 is 1 unit bigger than 0. So by symmetry, those two y-coordinates should be the same. And also by symmetry, the y-coordinates that go with -2 and +2 are also the same. Okay, but we'll plot these points. So -2, -5, -1, -2, 0, -1, 1, -2, 2, -5. Remember the formula for the x-coordinate of the vertex that was stated on the previous page? So x equals -b divided by 2a. Well, in each one of the quadratic functions that we've graphed so far, the value of b is 0. Each of those examples has an x squared term, but it doesn't have an x term. So that means the value of b in each of those is 0. So -0 divided by 2a is just 0. So x equals 0 for those 6 examples is the x-coordinate of the vertex. So that is, at least in the strategy that I use, when I pick my x values, I just pick 5 usually. I can pick more if I want. But the middle x value is the x-coordinate of the vertex. And in general, the formula for the x-coordinate of the vertex is -b over 2a. Okay, let's go on to the next page and look at some more complicated ones. Graph the quadratic functions. Identify the vertex, the X and Y intercepts, and the line of symmetry. So let's find the X coordinate of the vertex first. So the X coordinate is negative b over 2a. So in this one, a is 1, b is negative 6, and c is 8. We don't need the value of c to find the vertex. Okay, so negative b over 2a is the negative of negative 6 divided by 2 times 1, or 6 divided by 2, which is 3. Okay, that's just the X coordinate of the vertex. How do we find the Y coordinate of the vertex? Remember this y equals x squared minus 6x plus 8? This is a formula for finding the Y coordinate of a point when you pick an X coordinate. So the the Y coordinate of the vertex can be found if we replace every X with 3 and do the arithmetic. Okay, so 3 squared is 9. 6 times 3 is 18. So 9 minus 18 is negative 9. And negative 9 plus 8 is negative 1. So the vertex is the ordered pair 3, negative 1. What about the Y-intercept? What's true about every Y-intercept? Every Y-intercept has an X coordinate equal to 0. So to find the Y coordinate of the Y-intercept, we go back to the function and replace X with 0. And when we replace X with 0, we get Y equals 8. So the Y-intercept is the ordered pair 0, 8. For quadratic functions, that's one of the easier things that you'll ever have to do is find the Y-intercept, because the X coordinate is 0, so in the function, replace X with 0. Okay, what about the X intercept or intercepts, if there are any? Remember the possibilities? The graph of a quadratic function can have 2 X-intercepts or 1 X-intercept or 0 X-intercepts. Even before finding the X-intercepts, we can know how many there are going to be. So we have clues right in front of us. The quadratic function is y equals x squared minus 6x plus 8. The leading coefficient is positive, so what does that tell us about the parabola? Yeah, the parabola opens upward. The vertex is the ordered pair 3, negative 1. So relative to the x-axis, where is the vertex? Is it above the x-axis or below the x-axis? It's below the x-axis. So if a parabola opens up and the vertex is below the x-axis, how many x-intercepts are there? There are 2 x-intercepts. Okay, so how do we find them? Every x-intercept has a y coordinate of 0. So the procedure is replace y with 0 and solve for x. So replace y with 0, we get an ordinary quadratic equation, 0 equals x squared minus 6x plus 8. And we know how to solve any quadratic equation. This one, we can solve it easily by factoring. One factor is x minus 2. The other one is x minus 4. So the two solutions to that equation are x equals 2 and x equals 4. But remember, the x-intercepts are ordered pairs. So 2, 0 and 4, 0 are the x-intercepts. Okay, we're out of time. We'll pick up with this example tomorrow, and we'll probably go a little bit faster tomorrow, but it'll be over the same material.